Welcome everyone to this Milestone project section of the course. We're going to begin this section by going through a couple of warm-up project exercises. We're almost ready for you to begin creating a full interactive Python program. And for your upcoming Milestone project, you will be creating an interactive tic-tac-toe game. In order to warm up for this project, we're going to code along with a few exercises in order for you to see how to use Python code to do the following. Grab user input, manipulate a variable in your Python script or program based off that input, and then return back the adjusted variable. So you actually already know all the Python necessary in order to create something like a tic-tac-toe game. However, often for beginners, it's hard to see how to connect all these moving parts and pieces to create something that appears to be an interactive program. So that's why we're going to have just a couple of exercises and short lectures in order to show you just some simple examples of how this can be done. But first, let's just describe what an interactive program does in general. So you have to have some sort of visual representation that your user will see. So for example, here I'm using slides to actually display information. And then if you're building a game, that could be something like a tic-tac-toe board. So in any interactive program, there should be some sort of visual representation that a user can see. And then, in order to update this program, the user has to make some sort of decision and input that decision based off what they visually see. So for example, if you're playing tic-tac-toe, a user input would then be something like choose the top right corner for the O in order to win this game. Then that user input would go into some sort of Python function. Then, inside that Python script or notebook, we update whatever the board variable is, and then we have a new visual to show the user. And then we have the updated visual representation. And essentially, this cycle can happen over and over again in order to have just an interactive running program. So this is a very simple example for a tic-tac-toe board, but essentially, any interactive piece of software you've used follows some very simple logic like this. Now, the actual script that runs that can be extremely complicated based off how many options there are and how complex the calculations can be. But overall, you're just simply showing a visual representation, accepting user input, then having that be updated inside your Python script, and then showing an updated visual over and over again. So as I mentioned, most programs that are interactive work on this very simple idea. Display something visual to the user, let the user update through an interaction, update the variables within the program, and then those variables are then passed through in order to display the updated visual. So there's a connection there between the internal variables and what the user sees as the visual. So what we're going to do is in the next series of short lectures, we're going to guide you through examples of how to perform each of these individual tasks with Python. Keep in mind, there are many different ways of performing the same task, such as displaying output or manipulating variables internally in your Python script. So I don't want you to feel restricted by the examples we show here as the only way you can do this. These are just simple examples in order for you to kind of connect the dots between what you've already learned and creating an interactive program. Okay, let's get started. I'll see you at the next lecture. Welcome back everyone to this lecture on displaying information. And really what we're going to learn here is how we can combine a custom function using a def or def call along with the already built-in print function in order to show something to the user that actually displays like a board game, for instance. So let's go ahead and jump to a Jupyter Notebook and explore more of what I'm talking about. All right, here I am within a Jupyter Notebook. And as I mentioned, we already know that I can print out variables. So if I have a list, something like 1, 2, 3, I can simply print that out. And if I want to print out multiple lines, what I would have to do is have essentially a print statement for those lines. So let's say I wanted to print 1, 2, 3, and then maybe right below it, I also want to print out 4, 5, 6. And let's say right below that, we'll have one more list, 7, 8, 9. So when I run that all in one cell, I get back this display. Now instead of having to call each of these three print functions over and over again, what I could do is put all of this within my own custom function. So I'll say def, and let's say call this display. And let's imagine that we have 3 rows of information here. So I'll pass in row 1, row 2, and row 3 as arguments or parameters into this function. And then what this function does is it simply prints out row 1 on top of row 2, which is then on top of row 3. So I've defined the function, which means now I can display it. So let's go ahead and make an example row. And my example row for now, we'll just have it be 1, 2, 3, which means if I pass in example row for each of these rows, row 1, row 2, row 3, let's go ahead and pass it in 2 more times. So I'll say example row, and I'm just using tab here to complete this. Example row. When I run this, notice now, instead of having to call print, print, print 3 times, I simply call display once, and now it's flexible to whatever variables or parameters I have. And then the last thing I want to show you to kind of drive this point home of the flexibility of showing a display to a user is technically this doesn't have to be a list. This could be a string or any other object. So what I want to do is let's go ahead and make 3 unique rows. We'll say row 1 is 1, 2, 3, row 2, and what I'm going to do here is I'm actually going to have just some empty strings. And we'll have row 3 equal to, and we'll have another set of empty strings here. And in fact, let's just copy and paste this and make this row 1 as well. So we essentially have just 3 empty strings in 3 lists. So now I'm going to change this from example row to reflect row 1, row 2, and row 3. And something to keep in mind is this can go in another cell. So it doesn't have to be in the same cell. I could, in one cell, define row 1, row 2, row 3, and in the next cell then have this display function. So when I run this, I get back these lists with these empty spaces. And what we can do is later on in our program, let's say we've set up kind of a rudimentary tic-tac-toe board. I could say row 2, go ahead and grab the center position, which if we think about this, the center position here of this 3 by 3 is going to be row 2 at index 1 because we go 0, 1. So that means row 2 at index 1, and let's reassign this to be something like an X. And now what I'm going to do is display those rows again. Row 1, row 2, row 3. I run this, and now I see an X here. And this is a very rudimentary way of just taking in inputs and then displaying something that looks like something a user can visually interpret. This is just a very simple tic-tac-toe board. It's not the nicest looking tic-tac-toe board. You can get even more flexible with using things like strings in order to not actually see these quotes. So instead of having a list here, you would just kind of have this be a long string. And then you can add things like dashes in order to make it look even nicer. But this is just a very rudimentary display. And the next step we want to do is to be able to take in user input in order to have something like this, a reassignment of a particular position in a row or a list, be actually specified by the user themselves. So this is just our overall lecture on displaying information in a simple way that the user can understand. The next thing we want to do is be able to accept user input. So we've already gone over the input function in the useful operators lecture. So if you don't remember it, you might want to do a quick review of that lecture. But coming up next, we're going to expand on this idea of displaying information to accepting user input. Okay, thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to talk about accepting user input. Let's head over to the Jupyter Notebook and get started. All right, now previously we talked about just displaying information through a display function, which is essentially just a little placeholder for multiple print functions. Now what we want to do is accept user input, and I also want to show you just a couple of key things to be aware of when using the input function. Now we've actually already learned about the input function in the useful operators lecture, but here we're just going to show you a couple more things. So the input function is simply the keyword input, and then open and close parentheses, and what you do is you type out the string you want the user to see. So for example, we'll say, please enter a value, and then we'll have a colon and a space. And once I run this cell, what's going to happen is we'll see, please enter a value, colon, space, and then a little input box. So for example, I can say 2, then it just hit enter, and we get back the string 2. So what I can also do is, instead of just displaying the output here, I'll save it as a result. So I'll say result is equal to input, please enter a value, colon, space, shift enter to run this, and then when I say 2, we actually don't see the output result because I've saved it as a variable, which means I can now call result, and I get back 2. Now notice that the input function, whatever you actually pass into it, it's going to return a string. So if I check the type of this with the built-in type function in Python, it's str, which is a string type. If I wanted this to actually be some other type, such as a floating point or an integer, what I would have to do is convert it into an integer or floating point. And I can do that with the built-in casting functions, essentially. So I can say result is equal to, and then input, let's say enter value. We'll do shift enter to run this. I'm going to put in 2. And then once I have the result, I can convert it to an integer with int, open close parentheses, pass in result here, and then we'll say result underscore int is equal to integer result. Run this. And so the type of my original result is a string, and the type of my result integer is an integer. So essentially, this type in Python is also a function that allows you to convert from one type to another. So if I were to check the type of 2.3, for instance, it brings back float, which means float can actually convert to floating point numbers. So if I had a string, for instance, that was, let's say, 3.14, it actually converts it to the number, or floating point number. So keep that in mind, that the main thing here is input function is always going to return a string, which means you may need to convert it if you actually need a specific data type within your function. So that's going to be important, because if we have something like position index is equal to input of choose an index position, colon, space, later on I may want to use this position index as part of my list. So for example, we'll go ahead and run this, and we'll say 1, enter, and let's imagine I still have those rows above. So if I scroll up here, recall I have row 1, row 2, row 3, etc. So I have row 1 here, and I do shift enter. Unfortunately, I can't just say position index passed in here. I'll get an error. And that's because the list index, or list indices, they must be integers or slices. They can't be a string. So position index here is actually still a string. So really what's happening here is I'm trying to say row 1, and I'm passing in the string 1, which is the error. I actually need to pass in an integer, as we've already seen in the list lecture. So what I can do here is I can either cast position index or convert it into an integer type using int result or int position index, or to do this all in one line, I'm going to say int and wrap the input function around it. So essentially what this does is this grabs your input as a string and then converts it into an integer before assigning it to the variable position index. Let's go ahead and run these cells. I'm going to delete these real quick. So I'm going to do shift enter here, run this. It says choose an index position. Let's try again with 2, hit enter. And now what's nice about this is the type of my position index is an integer, which means if I take back, for example, one of those rows, let's say row 2, I can now pass in position index, and it works just fine. So this is the sort of thing you have to be aware of when using user input, is that Python will automatically pass it in as a string, and in order to use it in your program, you may actually need to convert it into a different data type, such as an integer or a floating point number. Now there's two more things I want to tell you before we conclude this lecture. The first one is if you're using some sort of conversion, such as trying to convert an input into an integer, it has to be a legitimate input, which essentially means it has to be something that looks like a normal integer, but it just happens to be wrapped in quotes as a string. So let's imagine that it says choose an index position, and the player types out 2 like this. Well, Python isn't actually smart enough to be able to convert this TWO into an integer directly. So when I hit enter here, I actually get this value error, which says, hey, invalid literal for integer with base 10, 2. Essentially saying, I don't know how to convert this string 2 into some sort of integer. So you have to be careful with that. And what we're going to do later on is actually show you how you can validate user input. So we'll be able to actually check to make sure that this is valid before attempting to convert it into an integer. So we'll learn about that in the next lecture. And the last thing I want to mention is the input function itself can be a little tricky because it awaits a user interaction, which means if you accidentally run it twice, your Python program or script may get stuck waiting for a reply that doesn't actually come. So I want to show you what that looks like. Let's say we have a result here is equal to input, enter a number, colon space. And I do shift enter, and right now, notice that there's an asterisk there, and it says, hey, I'm waiting for a result, please enter a number. If I accidentally forgot that I ran this cell, and I kept going down my notebook and tried to run another cell, such as 2 plus 2, this cell isn't going to run until you actually get a result here for enter number. So this is essentially waiting for the user interaction from the input. So it's only until I provide a number here and hit enter that the rest of the cells actually execute. And the other thing to remember, and this is the one that's really tricky with input, is sometimes people accidentally run the cell twice, which means we'll say something like input, enter number, colon space. I do shift enter, and then maybe I accidentally click on this cell again, and I'm going to hit shift enter again here. And now we're kind of in trouble because I accidentally tried to overwrite that input cell, but that initial input is still waiting for its interaction, its value, which means essentially now we're, for lack of a better word, screwed because we're still stuck waiting on that original input, and Jupyter Notebook has erased that first box because I tried to run this cell again, which now means any other cell, if I try to say, for instance, 20 plus 20, everything now is stuck waiting on that input that I no longer have access to. And unfortunately, if this happens to you, the only way to fix this is to go to kernel and then restart your kernel. You may be able to try to interrupt it, but typically the interruption doesn't actually work. So the best way to fix that is to say again kernel and then restart. And notice here we kind of saw the reloading of that restart. So now that it's been restarted, I can actually run any of these cells again, but the thing to keep in mind is all the previous variables in memory have been erased, and we're starting fresh from input 1. So now if I were to run this 2 plus 2 cell again, notice it's now the second cell. And all the variables I defined above here, such as result and row, they're no longer available to me. It'll say, hey, row is not defined, because in order to redefine everything after you've restarted your kernel, is you have to run all these cells again. So you have to say print this, print that, redefine these cells, etc. So you have to keep running all these cells. A quick way to do that though is you can always say cell, run all above, or run all below. So that's kind of a quick little tooltip there. Okay, so often a common mistake for beginners is they accidentally run an input cell function twice, and then you're kind of stuck. So if that happens to you, go ahead and just hit kernel, restart. All right, so we mentioned validating user input is going to be important. So let's go ahead and explore how we can do that in the next lecture. I'll see you there. Welcome back, everyone, to this lecture on validating user input. So we've already seen how to use the input function to interact with a user, and then how to convert that string data type from the input function into another data type, such as an integer. That way we can then use that input for other things within our program, such as indexing from a list. However, recall that if the user passed in something that couldn't be converted correctly, we would get an error. So what we want to explore now is how to further validate that user input to avoid errors for invalid conversions, and instead basically have a while loop that keeps asking the user for input until we get a valid input, and then continue on to the next step. Let's see how this is done by jumping to the Jupyter Notebook. Okay, here I am at a Jupyter Notebook. Recall previously we were playing around with this input function as well as coming back up and then trying to convert inputs. And the main thing to note here is that if the user provides an input which isn't correct for a conversion, such as the string TWO for 2 instead of just the actual number 2, then we're going to get this value error saying we can't actually convert this. So what we're going to do is use a while loop along with checking for the data type in order to not have this error occur, but instead keep asking the user for the correct input. In order to do this, the first thing I want to do is basically take what we have here through the input function and actually make it within our own custom function. So we're going to have def, and I'm going to call this user choice. It doesn't take in any parameters, but basically what it's going to do is say the choice is equal to the input, and then we'll say please enter a number, and let's just go ahead and say maybe 0 through 10. And then a colon space, and then it's going to return, and it's going to attempt to make that choice string into an integer. So we have that, and what we're going to do here is say user choice. Let's go ahead and run it. Again, we're not passing in any parameters. We just run this, and we can see this input function gets called. It says, please enter a number between 0 and 10. If we pass in, for instance, let's say 9, hit enter, it returns back the integer 9, not the string 9. Now, there's two problems with this right now. One is that, let's go ahead and run user choice again. I could technically try to, again, maybe provide a string 9. I hit enter, and I get, hey, we have an invalid literal for integer. The other problem with this is I'm specifically asking for the numbers maybe 0 through 10, and I'm not doing any sort of check to make sure that number is actually between 0 and 10. So if I were to run this again, let's say I enter something like 100, I hit enter, the function still works because it's able to convert 100 into an integer, but I'm outside the limits that I wanted. So 100 is outside the limit of 0 and 10. So there's a couple things we have to do. One is to make sure that the data type is valid in order to run this integer conversion. And two, check against the actual inputs I expect. So I can check against just a few inputs, or I can check within a list of inputs. And what I want to also show you is in the actual notebook that corresponds with this lecture, this warm-up project exercise notebook that I have open here, I've added some links for Stack Overflow. So if you just do a Google search for validating user input, so for example, here's a Google search for Python check if input is a number, there's lots of different ways you can do this. And I want you to explore these various methods. And I added a couple links here for specific Stack Overflow posts that answer this sort of question. Basically, how do I check if a specific Python input is a data type? And later on, we're going to be learning about things like try and except statements. But for these sort of simple checks, we actually don't need them. And there's lots of different ways you can do this. Here, there's a more advanced method such as try except, but there's also the isDigit, which returns true or false, a Boolean, depending if this can be converted into a digit. So there's lots of different methods here. So here's another while true with try except. Here's one that's basically a function, etc. And there's another Stack Overflow post that, again, checks if something represents an integer. And this one's without using try and except. So you scroll down here, lots of different ways. The isDigit ways, starts with, etc. So there's many different ways you can actually solve this question of checking for the correct data type input. The favorite method here that I found in my own research is that isDigit check. So this isDigit is probably the simplest way to do this. So that's what we'll go ahead and do. Keep in mind, it sometimes has errors for negative numbers, but for right now, we'll go ahead and ignore that test case. So we'll assume that the user is going to pass in a positive number. Keep in mind, you should always be careful with assumptions of what a user is going to do because users can often break your program if you're not checking for edge cases. But since we're keeping things simple, this isDigit should be enough for us. So we'll come back here and warm up project exercises, and we'll continue with validating user input. All right, so we already created this function, user choice, and I have two problems with it. One is a user can pass in something that isn't a digit, and two is a user can pass in something that's outside of the range I want. But luckily, I have this choice variable that I can then do checks against. So let's expand this user choice function. And based off that research from Google and Stack Overflow, I'm going to check with the isDigit method that's actually available on a string. So to show you what I mean by that is, let's say some value is equal to the string 100. So I run that cell, and in a new cell, I'll say some value dot hit tab in that new cell, and eventually you'll scroll down and you'll see that there's this convenience method of is alphanumeric, is alpha, is decimal, is digit, etc., is space, is upper, and really what I'm looking for is that is digit. So I'm going to say some value is digit, and I would never expect someone to memorize all these methods. Instead, you would do a Google search and Stack Overflow post search looking for the correct method. And if you do Shift Tab here, basically it's going to return true if all characters in this string are digits, which is pretty much exactly what I want. So open and close parentheses, since this is a method call, we run this and it returns true, since each of these is a digit, which means this can actually be passed into this conversion of an integer. So I can say integer some value, I run this, and I get back the integer of 100. Perfect. That's exactly what I want here, since we're looking for basically a whole integer number. So what I need to do is basically have a check to make sure that this choice is a digit. So how can we do this? To basically keep asking the question of the input. Well, what we need to do first is start off with a default choice value. So what I'm going to do is say my original choice value is something that is not an integer. So let's just start with wrong. And technically, this can be anything, any string you want, any variable you want, as long as it's not going to say true for isDigit. So obviously, the word wrong is not a digit. So we start with the wrong choice, and then I'm going to add a little bit of logic here with a while loop. Remember, a while loop basically continues until a condition is met. So I'm going to say while choice dot isDigit is equal to false, meaning currently our choice is not a digit. So while the choice is not a digit, and recall we start off with choice not being a digit, then I'm going to keep asking for this input, which means I need to indent this line in order for it to be part of this while loop. And this is where we're basically being a little clever here. What we're saying is we start off with this string, and since it starts off not being a digit, we're going to keep asking the user for input over and over again in this while loop until we finally get isDigit to be true. And since this while loop will continue to run until we have a digit, then I no longer have to worry about this conversion giving me a value error for something that isn't a digit, because this while loop takes care of that with this isDigit call. So let's go ahead, I'm going to delete these cells below. We'll redefine user choice, and let's see it run now. So it says, please enter a number between 0 and 10. Let's go ahead and pass in something like 2. I hit enter, and notice, because the string 2 is not a digit, so that means isDigit is equal to false, we simply ask the user again, hey, please enter a number between 0 and 10. And I can type in whatever I want here, but until I pass in that actual digit, such as 3, it's going to keep running and asking over again. So this is a really nice way to basically make sure that your user is inputting something that you expect. And as you can imagine, we can basically keep adding in conditions for this while loop with and or calls. Additionally, something we can do is add in an error message just so the user knows what happened. For example, after we get that choice, let's go ahead and just have another little check. We'll say if choice isDigit is equal to false, then I'll just print out a little error message for the user saying, sorry, that is not a digit. So we rerun this again. Notice that this if statement is within the while loop and it's in line with this choice. Basically, after the user gets a choice, we do a little quick check to see if it's false, and if so, we'll go ahead and print, warning the user that, hey, sorry, what you entered was not a digit. So essentially the logic is the same, but we added this little message just for the user's sake. So we'll say user choice, pass in 2, hit enter, and it says, hey, sorry, that is not a digit. And we can keep doing this over and over again. It's going to keep saying, sorry, that is not a digit, until we have something that is a digit. And now the last thing I want to show you to finish up this lecture is checking against multiple possible values. So remember we had this issue of this 0-10. So basically I want to make sure that the number is within a certain range. And there's lots of different ways you can do this, but probably the easiest way is to check against a list of acceptable values. For example, let's say my result is just the string wrong value. And I'm going to create a list of acceptable values. So acceptable values, and let's say my acceptable values are 0, 1, and 2. Then I can use the in operator. Recall the in operator was discussed in useful operators lecture, and it basically checks if something is in either a string or a list or any sort of iterable object. So I can say, is my result in acceptable values? I run that and it says false. This string, wrong value, is not within this list. I can also check for not in. So saying, is my result not in acceptable values? Run that, and that happens to be true because wrong value here is not within 0, 1, and 2. So that means you can add this sort of condition of make sure that the result is in acceptable values along with a condition that it's a digit, or you can have multiple checks later on in order to keep asking in case the user is putting in the wrong value. So in order to do that, we're going to reach a little bit higher level of complexity than we did before, but if you follow the logic, it's actually not too bad. What I'm going to do is scroll back up here and grab this user choice function again, and then paste it down here. And what I need to do is start commenting this just so we can keep track of our logic flow. First off, there's a couple of variables that we need. One are the initial choice, so we have some initial values here. And one is for the choice, which cannot be a digit in order to make sure this loop runs. The other one we want to make sure is if we have some sort of acceptable range. So let's go ahead and say that here, acceptable range. And you can either manually do this, something like 0, 1, 2, or you can use something like range. And since our range is 0 to 10, let's go ahead and say 0, 10. And if you're unfamiliar with the range function, go ahead and check out useful operators. Basically, it just makes an iterable that has the numbers 0 through 10 with a default step size of 1 integer. And finally, we need to have, just like choice, an understanding of whether or not we are within range. So I'm going to say within range is equal to false. Okay, so next step is to actually have the conditions we're checking for. In this case, it's going to be 2 conditions to check. I want to make sure that I keep asking in this while loop when my choice is a digit, so I need to check the digit, or I keep asking this if my within range is false. So basically, while the choice is not a digit, or when I'm not within range, so within range equal to false, then I'm going to ask for this input. And then if it happens to be a digit equal to false, sorry, that is not a digit. And now it's time to use this within range parameter in order to update it to true in case I do happen to be within range. So this is our digit check. And now let's add in a range check. So how do we do this? First, we confirm that we actually have a digit first. If not, we just keep looping. So we assume that by the time we're getting to the range check, that its digit happens to be true. So in order to do that, I'm going to say if the choice now isDigit, let's make sure we spell choice correctly. So if the choice dot isDigit happens to be true, then let's check if we are within range. So because now choice isDigit is true, I know I can cast that string choice as an integer and then check if it happens to be within my acceptable values or acceptable range. And if that happens to be true, then I know I'm within range, so I can update within range to be true. And keep in mind that the double equal signs is checking for equality. A single equal signs is an actual assignment. However, if that happens to not be the case, meaning I'm outside the acceptable range, then I'm going to say else I'm still within range is equal to false. Keep in mind, there's a lot of checks here that you technically don't have to do. For example, choice isDigit equals to true. This is actually a Boolean itself, so I could simplify things by actually just saying if choice dot isDigit. But for the sake of readability, I'll go ahead and keep a lot of these checks in place and also do things like keep assigning something as false, even though technically it's already equal to false. So this could have just been a pass. All right, so let's quickly go over the logic here that we added in. We have our initial values. The choice starts off as wrong. I have some acceptable range of values. And I'm also going to say that to start off, we are not within that range. So that means there's two things I need to check for. So either of these, if they're false, so if either the digit is false or within range is false, then I keep asking the user for input over and over again. So we first check if it happens to be a digit, and we basically warn them, hey, this isn't a digit, sorry, it's not a digit. And then we check if that does happen to be a digit, then we'll say if the integer choice is in acceptable range, within range is equal to true, else, let's go ahead and say else within range is equal to false, but let's also warn the user, hey, sorry, you are out of acceptable range, 0 to 10. And now we should be able to inform the user whether or not they're with a digit or if they're out of acceptable range. So there's a lot of lines and code going on here, but really take your time, review the notebook, and the logic should make sense to you. We're essentially just checking for two things here. Let's go ahead and run this, and now run user choice. So I'm going to do a couple of wrong inputs here. First, let's try an input that is not a digit. We'll say 2. And it says, sorry, it's not a digit. Perfect. And now let's try something that is out of range, like 100. And now it says, sorry, you're out of acceptable range. Now let's try something like 5. And we're good to go. Okay, awesome. So now we understand how to check if something is the correct data type and to check if something is an acceptable value, which are the two main things you're going to have to be checking when creating an interactive Python script. Coming up next, we're going to bring this all together, just a couple of functions, in order to show you how to create a simple user interactive experience. And after that, we'll set you loose on the Milestone project. I'll see you at the next lecture. Welcome back, everyone. To finalize this series of lectures, we're going to build a very simple game, which is essentially just an example of a simple user interaction. So we're putting everything together, and so what this program is going to do, it's going to display a list consisting of just 3 items. Then we're going to have the user choose an index position and an input value. So we're going to have to make sure that that index position is both within the range of 0, 1, and 2, and that it happens to be a digit. Then, once they've chosen a valid index position, we'll also have them choose just a string to input into that position. Then, we're going to replace the value of that list with the user's chosen input value. And we'll also check to see if the user wants to exit out of this game at any time. So we already have all the pieces needed. We just need to essentially string together the functions that we've already created in order to create an interactive user experience. So let's show you what the actual finished game looks like, and then we'll construct it ourselves using the functions we've already made. All right, here I am at the Jupyter Notebook. I've gone ahead and just copied and pasted some things from the lecture notebook, which are the functions we're going to be creating and coding along with in this lecture. We have one for displaying the actual game, one for the position choice that the user chooses, a second one for the replacement choice, essentially asking the user what they want to replace the current item with, and then a game on choice, which is really similar to the index position choice function, except it's checking to see if the user wants to stop playing. And then we have a little bit of game logic here, dependent on whether or not the user wants to keep playing. Okay, so let's go ahead and run this so we can see what the functions all look like together, and then we'll code it out ourselves. All right, so I run this last cell, and it says pick a position to replace 0, 1, or 2. First, let's try to pick something that's wrong, like 10. And it says, hey, sorry, but you did not choose a valid position. And it's going to be the same thing if we try to do something like 2. Sorry, but you did not choose a valid position. Now let's actually choose a position. We'll say index 1. And then it's going to say, hey, type a string to place that position. So let's just say new, run that. And now I can see the current list, 0, new, and 2. Would you like to keep playing? Yes or no? Let's go ahead and say yes. And here's the current list, 0, new, 2. Choose a position to replace. Let's go ahead and replace 1 again. And now we're going to replace it with something like brand new. Would you like to keep playing? Yes or no? So it says 0, brand new 2. I'm going to say no to keep playing. And there we have it. Very, very simple idea where I have this variable inside my Python script that the user can interact with. They can choose a position in that list and then replace it with their own value. So let's go ahead and build out this game. There's essentially a couple things we have to do. One is to have a function that can display the game. Second is to have a function where the user chooses a position. Third is to have a replacement choice function. Very similar, we just ask the user what string they want to choose. And then the game on choice, very similar to the previous two, basically asking, do you want to keep playing? So let's go ahead and then build out the game logic. I'm going to make a couple new cells here so we don't see that old stuff. And let's start off by creating the display function. So just as we did at the beginning of this series of lectures, we're going to go ahead and display that game list. How can I do this? Let's go ahead and make an example game list, which just starts off as 0, 1, 2. So my display function is essentially just going to be a print statement. It's going to say display game. It takes in the game list variable. It's going to print, here is the current list. And then let's go ahead and print that game list variable. Run that. Let's make sure this works by saying display game, pass in the game list, and we see here's current list 0, 1, 2. Very simple. And as you can imagine, this could be expanded to any sort of board game that you can display. You could display something like Battleship board games, etc. Okay, now comes the time to get a position choice. And this is very similar to the functions that we've been creating throughout the series of lectures. We'll say position choice. We'll say the initial choice is invalid. So we'll say the first choice is wrong. So how can we do this? Well, for this very simple game, I know that my choice has to be either 0, 1, or 2. Lots and lots of different ways you can do this. If you want, you can follow along with the previous methods shown, but I'm going to make this even simpler by saying, while my choice is not in, because there's only 3 options here, it has to be either the string 0, the string 1, or the string 2, because I know choice is passed in as a string from the input. So I'm kind of simplifying things here, but you can make it more flexible using the functions we've previously shown. And I'm going to say my choice is simply the input, pick a position, 0, 1, or 2, colon space. And let's go ahead and create a little message here. If the choice is not in 0, 1, or 2, and if you want, you could have made this a variable called acceptable values, then I'm simply going to say print, sorry, invalid choice. Okay, so that while loop keeps going over and over again. Once we have a valid choice, I actually want it as an integer, so I'm going to say return the integer choice. Let's go ahead and make sure this works. Position choice. Go ahead and run this. So notice if I type in a string, that's actually not in that list, so that's not going to work. If I type in something like 24, that's not in that list. So there's only 3 things I can type in order to close off this while loop. It's either a 0, a 1, or a 2. So if I say 1, then we're good to go. So that's the position choice, very simple function. And it's simpler than what we've seen before, but you could always expand this to be more flexible, given what we already learned. Next, it's time to choose a replacement. So let's imagine the player has already chosen their position correctly. They need to choose a replacement value. So what do they actually want to insert there? And in this case, we're going to take in two parameters. I'm going to take in the game list and the position. So this position choice is going to return position. And then game list will be a variable that I keep sending back and forth between functions in order to update it. So we'll say user placement is equal to input, and we'll say type of string to place at position. And then I'll simply grab the game list at the position previously passed, and then we'll say is equal to user placement, and it could be user choice or whatever you want to call this variable. And then finally, in order to keep passing that game list that's updated to different functions, I'm going to return that game list. So let's go ahead and check this out. We'll say replacement choice, going to choose my game list, and let's say my current position has already been returned as integer choice, so I'm going to pass in, let's say, 1 here. So I run this, it says type of string to replace at position, I'm going to say test. There we go. It returns that game list with 0, test, and 2. Perfect. Looks like replacement choice is also working. And then finally, we want to make sure that the user keeps playing. So let's go ahead and have something that's like a game on choice. And I'm going to copy and paste my position choice because it's so similar to the game on choice. I'm just going to edit it until it works for game on. So instead of position choice, we'll say game on. It's essentially going to ask the player, do you want to keep playing? So the choice starts off wrong, and there's only two options for the choice. It's either going to be yes or no. So we'll say while choice not in Y or N, ask the user, do you want to keep playing? So keep playing, question mark, and then we'll tell them that's either capital Y or N. And then if choice is not in Y or N, so we'll say copy that. We'll say something like, sorry, I don't understand. Please choose Y or N. And then finally, if that happens to be the case, then we know they have a Y or N. So I want to return whether or not they want to keep playing. So if the choice is equal to capital Y, then that's a yes, they want to keep playing, which means I'm going to return true, that the game is still on. Else, I'll say the game's over, and I'm just going to return false. So essentially what game on choice does is it asks the player, do you want to keep playing? It accepts either capital Y or capital N, and then returns a Boolean value that corresponds to those letters, whether it's true or false, which means I can use this choice to maintain some while loop. Let's go ahead and make sure this works. We'll say game on choice. Run this, and so it says, do you want to keep playing? If I type in something wrong, it says, sorry, I don't understand. If I type in Y, it returns back true. Let's run this again. If I type in capital N, it returns back false. Perfect. So now I have a function that basically asks the player, do you want to keep playing? And whether or not it's true or false. To finish this off, we simply have to put this all together. So we'll start off with some initial variables. We'll say game on starts off as true, and then we'll have our initial game list equal to simply 0, 1, 2. And so while the game is on, so I can do while game on is equal to true, or since game on is already going to be a Boolean, I'll just say while the game is on. Then I'm going to display the game, which means I have to display the current game list. Then I need to have the player choose a position. So I'll say position is equal to that position choice function we made. Then the player has chosen a position, which means we need to rewrite that position and update the game list. So recall we have this replacement choice function, which takes in the game list, and the position. And you should also recall, if we scroll back up here, that replacement choice returns that updated game list, which means I want to actually update game list based off that replacement choice. And then finally, we will display the game again, essentially displaying that updated game list. And this would just keep going on forever while game is on. So let's give the user a chance to say whether game on should be equal to false or not, which is this game on choice. So we'll say game on is equal to game on choice. Perfect. And that's the very simple logic we have here. Let's go ahead and run it, make sure it works. Okay, so here's the current list, 0, 1, and 2. Pick a position. Let's double check to make sure if I choose something wrong, it still works. Let's say if I choose 2, it says, hey, sorry, invalid choice. Pick a position again. Here's the current list. So let's choose 1, hit enter, type a string to place that position. We'll say my choice, hit enter, and now the current list is 0, my choice 2. Let's go ahead and keep playing. So you can see how the functions are being called in order here. Okay, here's the current list, 0, my choice 2. Let's pick 0 position, type a string, we'll say test, hit enter, and there's the current list, test, my choice 2. And I'm say all done playing, hit N, and the loop is finished executing. That's it. Okay, so we've definitely put a lot of pieces together in order to create an interactive Python program. And the main things we have to be aware of is the ability to display information to the user, accept information from the user, validate that information, and then update whatever the user is actually seeing. And with just a couple of functions, we can see that we're able to do that here. Displaying information, getting user information in order to validate that information, then update what we're actually displaying, that game list, and then getting more user information to see if we want to keep going with the program. Okay, you pretty much have everything you need within this lecture notebook and these lecture videos in order to make another higher level jump to program something that is a little more interactive, such as a tic-tac-toe board game. So let's get you ready by explaining your Milestone project coming up. I'll see you in the next lecture. Welcome everyone to your first Milestone project. You now know enough to actually create a real program. And so since this is your first Milestone project, we're going to create a tic-tac-toe game for 2 human players. Let's describe what the game will be like and what approach you should take when tackling on your first Milestone project. First off, the basic idea of the game is that 2 players should be able to play the game both sitting at the same computer. And the board is going to be printed out every time a player makes a move. You should be able to accept input of the player position and then place a symbol on the board. So we have these kind of larger problems, and what you should do when you're thinking about this Milestone project is try to break these down into smaller sub-problems. And that idea of breaking down the larger problems into smaller sub-problems is why we created a workbook, Jupyter Notebook for you that you can kind of go through and create functions in step-by-step fashion. Now let's describe the actual idea here of putting keyboard input and converting that into something that corresponds with a tic-tac-toe board. We're going to be using the idea of a number pad. So if you have a larger keyboard, often it has a number pad to the right of it. And we're going to match those numbers to the grid on a tic-tac-toe board. And it's up to you which way you want your number pad to go. On a keyboard, it looks like this, 1, 2, 3 at the bottom, 7, 8, 9 at the top. But often on an older phone model, when you deal with the number pad, it goes the opposite way. It has 1, 2, 3 on top, 7, 8, 9 on bottom. Again, totally up to you. The main idea here, though, is that in our mind, we're going to have a tic-tac-toe board over this number pad, and then a user, they're going to, using the input function, it's going to ask them, hey, where would you like to place your X or O? And then they'll provide a number that corresponds to the tic-tac-toe board, and what we're going to do is then print out the tic-tac-toe board with an X at that location. And then the next user is going to choose their number, such as 8, and that will put the next symbol, O, there. So we're going to alternate between X and O, ask the user for the input number, and then place that symbol on the board. And then later on, we'll check to see if someone has won or if there is a tie. Now, since creating your first full program is always a big leap forward, you're going to come out the other end a much better programmer. But since this is such a challenge, we've set up a walkthrough notebook to help guide you along with the functions that you're going to need to create. So let's explore what the game's actually going to look like once it's done. And then once we've done that, we're going to cover a few useful functions and go through the walkthrough notebook and show you just a couple of things to help get you started. Okay, let's jump over to the actual notebook that has the solutions. I'm not going to show you the solutions right now. I'm just going to show you what the game looks like when you run it. Okay, here I am at the solution notebook. I'm pretty zoomed in, so we only see a few lines of the solution code, but there's a lot more code through this, but I just want to show you what this actually looks like and an idea of what the game should look like when you run it. It doesn't have to look exactly like this, but this is the main idea. First, we ask the first player, hey, do you want to be X or O? So using the input function, we can pass in a string, X, hit enter, and then it'll say, hey, player one's going to go first. Are you ready to play? Enter yes or no. So then we enter yes, and then you can imagine that that's starting some sort of while loop to continue playing the game. And then we have choose your next position, and notice here we've been able to print out a board. And these are basically just print functions with kind of larger strings, and in the middle of some of these are going to be curly braces. You can't see them right now because they're empty, but they're curly braces that correspond to the index position of some list. And then when the player, using the input function, asks for the next position, let's put in 1, we can see here that we automatically draw an X at that one location. And then the next player says, hey, choose your next position. Let's have them choose 8 like we did in the slides. They hit enter, and now we have O there. And then we choose the next position, and so on until someone's 1. So I can say 2 here, and we'll have, let's say 9 for O, and let's make X win by putting in 3. So here we have 3 in a row, tic-tac-toe has been won, and it says, congratulations, you have won the game. And then we ask the player, hey, do you want to play again? Enter yes or no, and let's enter no. Hit enter, and that breaks this cell. So you can see here, there's a little hint here, if not replay. So we can see here, replay some sort of function that was accepting yes or no there. All right, so that's the basics of what it should look like. Let's now hop over to the workbook notebook, explain what that looks like in order to get you comfortable with the idea of lining up these functions. And then we're going to show you a couple of useful things in case you want a little head start on the solutions. All right, so the actual notebooks, if you go to Complete Python 3 Bootcamp, either you've downloaded this or you're at the repo, come over to Milestone Project and you'll see a couple of useful notebooks. One is the assignment notebook. This assignment notebook is just a description of what it is you need to do. It's basically the notebook that corresponds to the lecture right now that you're viewing. And it looks like this. It just says congratulations and a couple of bits of information. The notebook that you're mainly going to be working with is this Walkthrough Steps workbook. And this notebook looks like this. So this is the Walkthrough Steps workbook, and this is something we designed to help you guide you through the functions that you're going to need to create. It has some suggested tools, such as the input function that you've seen before, and then it also notes that if you want the input to be an integer, it may be a good idea to cast it to an integer using int. Then we also have some information about how to clear the screen between moves. This is a special Jupyter Notebook function. There's also kind of a simpler way to clear the screen, which is just to print 100 new lines, and then you can scroll up to view the previous boards. All right, so what does this actually look like as far as a workbook notebook? Well, we've divided up the entire project into steps, which have placeholder functions for you to fill out, and then we have tests for each of those steps. And you can see here step 2, test step 2, step 3, and eventually you go along, and at the very end, there's going to be less tests because you won't really need them. And finally, there'll be kind of some ideas of how you should set up the logic for the game. So what does these functions actually look like? Well, for instance, the very first function wants you to write a function that can print out a board. So you set up your board as a list where each index 1 through 9 corresponds to a number on the number pad, so you get a 3x3 board representation. So what this is expecting to happen is when you pass in a board list into this display board function, you actually print out that board. That way, later on in your code, you can actually call this function and it will continually print out the board whenever you want it. So in order to test this function, we have test step 1, where we've created a test board for you, some board that's already full, and then you can say display board. Then the next one is to write a function that takes in player input and assign their marker as X or O. Think about using while loops, and we continue along with these cells. All right, so that's the basics of the workbook. Now, since this is such a big project and it's going to be kind of a big leap forward. What I would recommend you do is if you ever feel uncomfortable, jump to the solutions and treat it as a code along lecture. And then once you're done coding along with that, see if you can come back and independently fill out some of these functions on your own. And that will really help you connect the dots of dividing this problem into smaller subproblems. Okay, so that's the main idea of the Milestone project. If you want, right now you can just stop this lecture, go ahead and jump to it. And you can also just open up a script or open up an empty Jupyter Notebook file and see if you can do this all on your own without the workbook. What I'm going to do now is give you a little bit of a head start because I know it can seem very daunting. I know a lot of students, they look at this step one and they just get totally stuck. There's kind of this roadblock in their mind of where to actually begin. So I think it's really helpful if you're completely stuck on the idea of how do I even approach this task. I'm going to show you a way you could display the board, and then I'll show you a little bit of step 2 and a little bit of step 3. So these are just hints. It's not the full solution walkthrough. It's just something to help get you started. I'm going to open up this workbook in a Jupyter Notebook and continue on. If you don't want any hints on how to get started, go ahead and just stop the lecture here. Okay, let's go to the Jupyter Notebook. Okay, here I am at the walkthrough steps workbook. I'm going to work through the couple of first steps just to give you a little help pushing you forward through this project. Again, if you want to tackle this on your own to start off with, you can stop watching the lecture. First thing we're going to do is discuss actually printing out the board. So as we mentioned, we kind of want you to set up the board as a list that looks like this. And at first, that test board list or the board list is going to be empty, and we're going to use user input to index this list and then assign it the actual string value. So how do we actually display this board if it's a list? Well, we could just use a bunch of print functions. And I'm going to do a very simple version of the board here, where I'm going to say print, let's say the board at index 1 plus, as a string, some pipe operator, and then the board object at index 2 plus some pipe operator, or any symbol you want really, and then concatenated with board at index 3. And then we're going to copy this and fill out the rest. So we'll say this and this. So 1, 2, 3 is at the bottom. Again, you can kind of reverse that if you want. And we'll have 4, 5, 6 here. And then 9, 8, and 7. And let's run this and see what happens. Whoops, I have invalid syntax. I forgot the plus sign here. Plus, plus, plus. Okay, now when I run this, what I'm doing here is I'm going to print out whatever string is at board 7, a pipe operator, then whatever string is at board 8, another pipe operator, and then board 9. This is not going to look as nice as the tic-tac-toe board I just showed you, but it should work to some degree. So I rerun this, and let's display the board. So I'm going to pass in this list. I run this, and here's my board, XXX000, or 000. And that's the basic idea of displaying the board. And then later on, you can get a little fancier. If you want those horizontal lines, all you need to do is just print out a couple of dashes that maybe look like this. That's probably way too many. Let's just do something like that. And now when I rerun this, you can see how that's slowly starting to kind of affect the board there. And maybe you want uppercase dashes yourself. So maybe you want something like these pipe operators here, start lining them up, and you can start to get really clever with the way this is going to look. So that's the basic idea of just displaying the board. We've taken the board itself as a list, grab the index positions, and then we will print out whatever value is there. Now keep in mind your test board at the very start of the game is going to be probably a bunch of empty strings. So it's probably realistically going to look something like this. We'll say just times 10 here. It's going to look like some sort of empty board. So if I rerun this, it'll look like that. So that's how the board starts off, and then as people start actually putting in X's and O's, it will clean up the board. Now, if you keep calling display board multiple times, you'll be able to see a history of the board. If you don't want that, what you could do is clear the output from the previous board. So later on, you can experiment with running this clear output line, or if you're running a Python script, running this line right here, which kind of prints out 100 new lines. And what this does is because later on during your logic, if you keep asking to display the board, it will show you an entire history of all the print functions or print statements you used to do. what you could do instead is clear the output and then only show the board itself. That way it actually appears to the user that the board is being updated instead of printing out a new version of the board. So you can play around with this to get an idea of what I'm talking about, and you should be doing this before you actually print out the new version of the board. So that's how you could display the board. And I'll give you a couple more hints about step 2. Okay, the next thing we want to do is write a function that could take in a player input and assign their marker as X or O. And we want you to think about using while loops to continually ask until you get a correct answer. And there are a ton of ways you could do this, but I'm going to show you just a quick example way so you can hopefully get the mindset ready. One way is to set your marker as an empty string. And then what we're going to do is keep asking one of the players, such as player 1, to choose X or O. And then once they've chosen, we'll assign player 2 the opposite marker. So how can we keep asking player 1 to choose X or O? Well, we can say while the marker is not equal to X and the marker is not equal to O. So that means the marker is both not equal to X and not equal to O, meaning someone hasn't supplied the correct input. What I'm going to do is set marker equal to the input player 1, choose X or O. That way if the player accidentally puts in a number or puts in another letter, it just asks them for the input again. And then once we have that input, what I could do is say player 1 is going to be equal to that marker, and then we'll have a little if statement here for player 2. We'll say if player 1 is equal to X, player 2 will set that equal to O. Else, player 2 is then equal to X because we know player 1 chose O. And finally, what I could do in order to return both player 1 status and player 2 status for their markers, I can return this either as a list or a tuple. That way I can use tuple unpacking later on. So I can say return player 1, player 2. So let's run this and make sure it works. So I'm going to call player input function here, run that, and it says player 1 choose X or O. So let's give it a wrong answer and see what happens. Okay, let's give it a number, see what happens. So it keeps asking us, hey, choose X or O. So if we choose an X, then it reports back, okay, X and O. So player 1 is now X and player 2 is now O. And the way you can work with this is actually assign them to a tuple. So what you could do is say tuple unpacking in the following form. Create player 1 marker variable, comma, player 2 marker variable, and set that equal to the output of player input. That way, when you run this, and you actually choose a value, O, you can then say, hey, what was player 1's marker later on in your code? And it'll tell you it was O. And if you ask for player's 2 marker, it was X. Okay, so those are a couple things to help you get started. In the next lecture, we're going to go over all the formal solutions, and we'll see you there. Best of luck on your first Milestone project. If you ever get stuck or have any questions, feel free to post to the Q&A forums. We'll see you there. Welcome back, everyone. In this lecture, we're going to formally go through the solutions for the workbook for the Milestone Project 1, that tic-tac-toe game. Let's open up the notebook and get started. All right, here we are at Milestone Project 1 Walkthrough Steps workbook. Let's start with step 1, which is to create a function that can print out the board. And there's lots of different ways you could have printed out the board. You could have gone with a really fancy board or a really simple one that just displays the list. But remember, we're expecting board to be a list. So the first couple things we're going to need is to actually print out the index positions of that list. So it'd be nice if we did something like board at 1 plus, and then some sort of indicator that we have a new column there. So we can do that. And then we'll do board at 2 plus, and then another pipe operator. And then finally board at 3. And then I'm going to just copy and paste this. And now let's change up the index positions. So 7, 8, and 9 on top. And it's up to you if you want to reverse that, but 4, 5, 6 will always be in the middle there. And let's check what this looks like if we display the board. So we run this, we display the board, and right now my test board is blank. So let me copy over the test board from the original workbook. And now when I run this, I get back my board. So this is a really simple version of the board, but it works fine. Now, something to note here is that if I run display board multiple times, so let me call it twice here, what's going to happen is I actually see a history of all the boards here. So in order to avoid that, what we could do is call clear output first. So if I call clear output, and as an alternative, if you're running this at the command line, you can use this print statement we talked about. If I now have clear output, what's going to happen is I only see one version of the board. So this would display the board, and the next time the board gets displayed, so next time you call display board, it's going to clear the output for you. So this is a really simple version of printing out the board, and we can keep it for now, but I'm going to copy over and paste the solution workbook, which is essentially the same idea. It just has a little sleeker bit of formatting here. So if I run this, I get back kind of a more spacious board to look at. It's up to you what you want to do here. Lots of different options. Main idea was to be able to index board and then print it out. Step 2 was to write a function that can take in a player input and assign their marker as X or O. Again, lots of different ways we could do this, but something we definitely wanted to do was to use a while loop. That way we can continually ask until you get a correct answer. So I'm going to set marker as an empty string, basically anything that's not X or O. And I could do this two ways. I could say while marker is not equal to X and marker is not equal to O. So I could do it this way and then say marker is equal to input player 1 choose X or O. And then what I can do is uppercase this in case they accidentally put in a lowercase x or a lowercase o. And finally, I'll return some sort of tuple assignment. So I'll say if marker is equal to x, return x comma o. And so the format here, I can write myself a little note. And in fact, this would be a good case for a docstring, is to say that the output is in the form of a tuple with the player 1 marker, comma, player 2 marker. So then when I check player input, the docstring is going to tell me what the actual output looks like. So you can check out the previous lecture for a more detailed version of this. This is kind of a cleaner version. Then we'll say else return O and X. And this allows us then to use tuple unpacking. So if I run this, then I can use tuple unpacking something like this to get back player 1 marker and player 2 marker. So I run the input, if I pass in X, hit enter, and I check out my player 2 marker, it's going to be the opposite of X, which is O. And if I check out my player 1 marker, it's going to be X. So different ways you could do this. The other thing I wanted to mention is instead of doing it with not equal to and not equal to, you could have said, well, not marker equal to X, or marker equal to 0. So you could have said, while not this case or this case. So different ways to think about it logically. It's kind of up to you which you prefer. Moving on to step 3, we wanted to write a function that takes in the board list object, a marker, X or O, a desired position number, 1 through 9, and then assigns it to the board. So what we can do here is say place marker, board marker position, and I will say board at that position is equal to marker. So let's run a test to make sure this actually works. What we're going to do is say place marker. I have right now a test board. So if I take a look at what my test board looks like, it's the one from above, where I have a hashtag first to kind of block out the 0, and then X's and O's. I'm going to say, put in something new there. So let's make it really obvious with a $, and then put it at position 8. So I'm going to place the marker and then display the test board here. So let's run that, and we can see that it successfully put in the $, at the position we want. And that was just a simple, basically, at that board's position, place the marker there. Okay, step 4 was to write a function that takes in that board list and some marker, like X or O, and checks to see if that marker has won. So we have to ask ourselves, what does it mean to win tic-tac-toe? Well, it means that we need to check in the possible combinations. So we know that there's going to be 3 across. So we need to check all rows and check to see if they all share the same marker. So if they all share the same X's or they all share the same O's. So we need to do that for all the rows. Then we need to do that for all the columns. So that's going to be 3 columns there. Check to see if marker matches. And then finally, we have 2 diagonals to check. Diagonals. And check to see if we have matching there. Now we can use indexing to grab the example rows, the example columns, and the example diagonals. I'm going to show you different ways to do this, and then we'll copy and paste from the solutions because it's a lot of checks. So one way we can check for everything matching on all the rows is the way we showed you in the solutions notebook, which is to say board, let's do the bottom row. So we'll need to check board of 1 equal to the mark and board of 2. Let me make sure I check that right. Board of 2 equal to the mark and board at 3 equal to the mark. So what this does is it goes ahead and checks, hey, is the position at board 1 equal to the marker? Is position at board 2 equal to that marker? Remember that marker is the same that you passed. It's either going to be X or O. So if it passed an X, it's going to say at this position is it X, and at this position is it X, and at this position is it X. If we have this case true, then we know someone has won. It's whatever this mark is, has won. And in that case, we would just return back some sort of Boolean that they've won the game. And then what we could do is wrap this in a parentheses right here, and then have an OR statement, and then check for the next row. So we could say board at 4 is equal to mark, and so on, 5, 6. Then the next one would be 7, 8, 9. And then we could do the same for the columns, and the columns would be things like 7, 4, 1, 8, 5, 2, 9, 6, 3. And then we have the 2 diagonals, which is going to be those numbers, 7, 5, 3 and 9, 5, 1. Now this is how we did it in the notebook solution because it's a little more obvious what's happening here. But as an alternative, instead of using these AND operators along with checking mark for each individual index position, what you could also do is just check that board of 4 is equal to board of 5 is equal to board at 6, and then finally check that this is equal to the mark. The reason you cannot just do no check to the mark is because if the board starts off blank, then it's going to report back, hey, these 3 blank positions match and someone's already won. So then you have to check it off with the mark finally. So this right here is the same logic as what we saw up here. It's just maybe a little sleeker, a little cleaner. It depends to you what is more readable. But I'm going to copy and paste this from the solution notebook because it's a lot of checks. And if you want to be a little clever, you can make a little for loop for the rows and a little for loop for the columns, and then manually write in the diagonals. But let me copy and paste the solution and briefly go over it. Basically what we're doing here is we're doing that first way I mentioned. We're checking across the top, across the middle, across the bottom, down the middle, and then down the other columns, and then the 2 diagonals. All right, and what we're doing here is then we have an OR statement for each of these possible checks. And then after all of this, we're going to return the Boolean indicating true or false has somebody won. So we can have a win check here. Let's define this, win tic-tac-toe, the win check, and it looks like someone did win this tic-tac-toe. So let's actually display the board so we can see that. Display board, test board. So if we see this, definitely X has won in both fashions here, and it returns back true that this person has won. Great. So now step 5, we want to write a function that uses the random module to randomly decide which player goes first. And as we mentioned, you may want to look up random.randint. We talked a little bit about it in the useful operator lectures, but let's take a closer look now. One way we can use the random.randint is to just pass in 0 and 1 and treat that as what is essentially a coin flip. So we can say the following. We'll have our flip number be equal to random.randint 0, 1. So this is randomly going to choose either 0 or 1. So we can think of that as heads or tails. And then we'll say if the flip is equal to 0, then we return let's say player 1, as they're going first, else we return the string player 2 for going first. And there's lots and lots of different ways you could have done this, but this is kind of a simple way with the random.randint, or random integer function. So let's run that. Okay, step number 6 was to write a function that returns a boolean indicating whether a space on the board is freely available. So it's going to take in that board, which is a list, and then take in a position, and it wants to check if it's freely available. And for our case, freely available means that that position is currently an empty string. So to do that, what I'm going to say is get the board at that position, and then see if it equals a blank string. And since that's already itself going to be a boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a boolean value. True if full, false otherwise. So to do this, we're going to run a for loop that goes for I in range 1 through 10, because there's 9 spaces on the board starting from 1 and then up to, but not including 10. We're going to say if, and then we can call our space check function that we just defined up here. So if space check, using that board at position I, so that's all the positions possible on the board, if space check returns true, then I'm going to, and this is kind of a double negative here, but we're going to return false. So what this means is, if I have a space, that means my board is not full, so I will return false. Otherwise, if I go throughout this entire for loop and I don't return false, then I'll return true because my board is full. So board is full if we return true. Okay, so that's the full board check function. Step 8 is to write a function that asks for a player's next position as a number 1 through 9, and then uses the function from step 6 to check if it's in a free position. If it is, we return the position for later use. So we'll do the following. We'll say position, and we'll have it be a placeholder at 0 because we know that at index 0, nothing's going on there. And we can say while position is not in the list of possible positions, so that can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could have used range along with a list to make that happen. Or that space is not free, so we can say or not space check at board position. We'll ask the player for a position. We'll say position is equal to the integer of the input. Choose a position 1 through 9. And then finally, after all this, we're going to return that position. So all we're doing here is the following. We'll say position starts off at 0, and while the position, if the player for some reason is inputting the wrong number, or if they're inputting a letter, that's going to be this check to see if it's an actual number that's on the board, or it's going to check, hey, is that space still available? And then we're going to return the position once these have been satisfied. So we should only be calling player choice later on after we check if the board's been full. So the board being full is going to be a nice way to check if there's a tie, because if the board is full and nobody's won yet, then we know there's a tie. Okay, step 9 is to write a function that asks the player if they want to play again and returns a boolean true if they do want to play again. So lots of different ways we can do this. One way is to just say input play again, question mark, enter yes or no, and we're going to say that's going to be their response. Let's just have that be their choice, and we'll say return choice equal to yes. So here we're assuming the person is actually putting in the correct values. If we get choice not equal to yes, basically they have to write yes perfectly, otherwise we'll assume they don't want to play again. All right, and that's our replay function. Now step 10 is the hardest part, where we actually have to code out all the logic. So this is going to be our largest block of code, so we'll finish this off in the next lecture. We'll see you there. Welcome back, everyone. So finally, it comes to step 10, which is the harder part, where we need to use while loops and the function we just defined above in order to actually run the game. So let's write out a little bit of logic and comments on the steps we need to take. So first off, we're going to need some sort of while loop to keep running the game. And then probably at the bottom of this while loop somewhere, we're going to break out of the while loop on the replay function. So remember, the replay function just asks if they want to play again. So if they don't want to play again, we'll break out of this while loop that continually runs the game. So let's do that right now. At the very top, we'll just print welcome to tic-tac-toe. Tic-tac-toe. And then we'll say while true. And then we're going to play the game here. And finally, somewhere at the very bottom, we'll ask for the actual result of that replay. So we'll say if not replay, break. Because after they've played the game and somebody's won or there's been a tie, we're going to ask them, we're going to call replay and then break out of this continuous while true loop. Again, you should always be very careful with these true loops. There should always be a way to break out of them. Now it's time to play the game. So in order to play the game, we first need to set everything up. And what I mean by that is like the board, who's first. And then the other thing we probably need to set up is what markers they choose. So we'll say choose markers. So those are X's and O's. Okay, so we need to set those things up. And then after that, we'll have some sort of actual gameplay. And the gameplay will probably consist of player 1 turn, and then player 2 turn. So let's start off by setting everything up. The first thing we want to set up is the board. This should be pretty straightforward. We'll just set up a board, and in my case, I'm going to set up the board as a bunch of empty strings because when I set up the display board function up above, I expect it to be kind of a bunch of empty strings there. There's lots of different ways to do this, and it really depends on how you set up your display board function. But in this case, I'm going to set up my board as just a list of 10 empty strings. And I will say that player 1 marker, comma, player 2 marker are going to be the result of player underscore input. So if we scroll back up to realize what player input was, remember that's one of the very first functions you actually created, which asked what player chose X or O. So we're going to say player 1 marker is equal to X, and then player 2 is equal to O, or the opposite, because we're using tuple unpacking here. So that's what we're running, that very first player input function. So we're calling that all the way at the bottom, and I set their actual markers. That way I can call those variables later on. Then we need to choose who goes first. So I'm going to say turn is equal to the function call, choose first. Remember that was basically that coin flip function. And then let's print out a little report. We'll say turn will go first. So here, if we remember what turn is, choose first actually literally returns just a string, player 1 or player 2. So we're going to use that as the indicator of who's going first. So we say turn choose first, player 1 or player 2 will go first because turn is the actual string. So we concatenate it. And then finally, once this is ready to go, let's ask if they're ready to play the game. So we'll create a variable called play game, and the input will be want to play. I should say ready to play, really, because we already have a bunch of stuff. Ready to play. So they've set up the players, we decided who's going to go first, and we asked them, are you ready to play? And we'll have them say lowercase y or n. And it's up to you how you want to do this. We'll say if play game is equal to y, then the game is on. So I'm going to create a variable called game on and set it equal to true. If for some reason they weren't ready to play yet, we'll just say game on is equal to false, and that will be it. Okay, so now it's time for the gameplay. We'll assume that game on is true, and then we'll say while game is on. So we have player 1 turn. So let's say if turn is equal to the string player 1, we'll have player's 1 actual turn, and otherwise we'll have player 2 turn. So off of this we'll say else, and this is player 2 turn. Okay, so let's set up the logic on player 1's turn. So what do we actually need to do here? Well, the first thing we want to do is display the board. Otherwise, the player won't know what the heck they're looking at. So we'll say display board, and we'll pass in that board object that we just created. And the next thing we do is, well, let's write out the steps here. We'll show the board. Once the player's seen the board, they can choose a position. Once they've done that, we will place the marker on the position that they chose. And then we just need to check if they won or check if there is a tie. And then finally, no tie and no win. Then next player's turn. So that's the logic of what we're going to do here. And this entire logic is going to be the exact same thing for player 1 and player 2. We're just going to edit the actual variable names. So we showed the board. That's easy. That's the display board function we defined earlier. Now we want to choose a position. That's also pretty straightforward because we actually already have a position function called player choice. So remember that if we call back player choice, and let's make sure we've defined it up here. So player choice was just this one right here where we have them choose an actual position on the map, or I should say on the board. We say position is equal to player choice, and we pass in the board here. And then finally, we're going to call the place marker function, where we take in the current board. We say player 1 marker because this is the player 1 turn, and then we pass in the position they chose, which is defined up here. So we showed the board, we choose a position, we placed a marker on the position, and now we need to check if they won. Again, we already defined the function for that. It was called win check, and it takes in the board, and then that player's marker. In our case, it's going to be player 1 marker. And we can display the board. So if win check happens to be true, then player 1 has won. So in that case, we'll display the board and print out player 1 has won. And once somebody's going to win the game, we'll just say game on is now equal to false. So the game is no longer active, which will break out of this while loop. We'll still have this while loop right here asking people if they want to play again, but this while loop of the actual gameplay will now be broken when we say the game has been won. So if we don't have a win, then this doesn't execute, which means we should check if there's a tie. So how do we check if there's a tie? Well, we can check if there's a tie if the board is full. So if we've already checked and nobody's won, then we should check if the board is full. And if the board is full and nobody's won, then that means we have a tie. So we already actually have a full board check, and let's check it up over here. Remember over here we have the full board check function, so we're going to be using that, and returns back the Boolean, true or false. So we'll say if full board check on the current board that we're kind of passing around here, we'll display the board. So this means that someone hasn't won, and else if the board is full, we'll display the board and then we'll say something like the game's a tie. So tie game, and then we will break out of the loop. We could also set game on equal to false, either way. And then we can set turn equal to player 2. So let's actually just keep this game on convention. So instead of breaking, we'll say game on is equal to false. So what's actually happening here? For player's 1 turn, we display the board, we choose a position, or player 1 chooses a position. We put that marker on the board. We check if they've won. If they did win, game on is now equal to false, and this entire while loop is over. If they never won, then we have two things to do. We need to check if the board is full. And if the board is full, then it's a tie game. We print out the board, show them what it looks like that is full, and we say game on is equal to false, and this entire while loop is over. Otherwise, nobody's won. There's still space on the board to go. That means it's time for player 2 to go. And we're going to essentially copy and paste all this code because player 2 is going to do a really similar thing. It's just wherever player 1 is, player 2 is going to be, and vice versa. So let's delete these comments here. And now we have this else statement. And I'm going to zoom out just a little bit so we can see the entire logic here. Notice how I have if turn is equal to player 1. That's this entire block of code. Else is now lined up with this if. So else here signifies that this player's 2 turn. And I'm going to paste all the code here. So same thing, I need to show the board, I need to choose a position, I need to place the marker, except this time it's going to be the player 2 marker. So that's a change we're making. And then we want to win check for, again, the player 2 marker, and we display the board, and in this case, player 2 would have won, and we set game on equal to false. Else, we say if full board check, display the board, tie game, and finally, if player 2 didn't win and there's no tie, then we go back to turn being player 1. And that's it. That's player 2's turn. And let's check this out and see if it actually worked. We'll run this code. We'll choose X for player 1. We'll say ready to play. Yes. Choose a position 1. And let's kind of play this out. We'll keep going like this. And then we should see player X win. So player 1 has won. Perfect. And let's go ahead and play again. Okay, so we just saw how the win works. Now let's run this again and check to make sure that our tie checking is also working. So I'm going to type in O. So player 1 is going to be O. Player 2 will go first. So that means X is going to go first. We're ready to play. Time to choose a position. And hopefully I can actually get a tie here. This is harder than it looks to play against yourself and try to purposefully tie. But I will do my best here. Let's say 2. Let's say 4. And now O is going to block him at position 7. And then X will have him go, let's say, position in the middle, 5. We'll have O block him at position 9. And then X will have him go kind of somewhere useless, let's say 3. And then O will purposefully block off X here, and we'll have him go at position 6. And then finally, we'll have X go in at position 8. And it's a tie game, so the tie check worked as well. And we no longer need to play again, so we'll say no. And that's it. That's the game. All right, so definitely a really big project, but hopefully now that you're on the other end of it, you were able to see how you can use functions to create a larger block of code. Now, if you were treating this as a code-along project, what I would highly suggest is if you just viewed the entire solutions, go back and see if you can now go through the workbook notebook on your own after you've referenced this entire solutions code. It's going to be a really great help to your skills to be able to try to attempt this independently, even if you already watched the solutions lecture. All right, thanks everyone. If you have any questions, feel free to post to the Q&A forums, and I will be there to help you out. I'll see you at the next lecture.